In this video, we're going to use 2x2 systems of equations to solve different application problems. In Alaska, the average of the per capita incomes for Alaska and Arizona was $28,000. The per capita income in Alaska exceeded the per capita income in Arizona by $4,000. We want to find the per capita incomes for each state. So the first thing that we need to do is we need to figure out what our variables are going to represent and how we're going to define them. So our question is to find the per capita incomes. That's what we want to solve. So we're going to use that last sentence in order to define our variables. We're going to let X be the per capita income in Alaska and Y be the per capita income in Arizona. Next, we're going to take all of this information and start to figure out which parts of it is the most important. The first piece of information that I notice is that the per capita incomes for Alaska and Arizona is $28,000. My variables are defined to be the per capita income in Alaska and Arizona separately. So if I add them together, it should total the per capita incomes for both states. Notice how when I defined my variables, I didn't just put X equals Alaska or Y equals Arizona. The reason why is because that really doesn't make sense. You need to really be specific in what your variable is representing. A lot of the problems with solving systems of equations is when we go back to kind of figure out what do those numbers mean, or how do I take the information in the problem and make equations out of it, all depend on those variables being specific. So I do expect you to write your variables as a complete sentence, just like everything else. The next piece of information that I noticed is that the per capita income in Alaska exceeded the per capita income in Arizona by $4,000. Well, the per capita income in Alaska is defined as the variable X. It exceeded, so it is the per capita income in Arizona, which is Y, plus another $4,000. So X is equal to Y, so the income in Alaska is equal to the income in Arizona plus another $4,000. Now I have two equations and two variables, so I can use either substitution or elimination in order to solve it. I wouldn't use a graphical or numerical approach just because they're not as precise as an algebraic approach. So seeing how this system is set up, I'm just going to use substitution. I'm going to substitute X equals Y plus 4,000 into the X of the top equation. I'm going to combine my like terms, subtract the 4,000 to the other side, and then divide by 2. So I get Y is equal to 12,000. I now have to go back and find what X is, since I need to have both variables accounted for. Well, X is equal to 12,000 plus 4,000, which is 16,000. Putting that all together, we have that the per capita income in Alaska was 16,000 and in Arizona it was 12,000. In our next example, we have a person has $200,000 invested, part of it's at 8% and part of it is at 9%. If the total yearly income for the two investments is $17,200, how much is invested at 8% and how much is at 9%? So this is a very classic mixture problem. So we have a quantity, right? We have money, and then we have rate. So we have percentages here. So when I have a mixture problem, this is one type of it where we have investments, we have percentages, and it has to do with money. Another type of mixture problem you may have seen is when we have solutions. So say you're mixing two different kinds of solutions together to produce a different kind of solution. That comes up a lot in like chemistry classes. They both follow the same kind of protocol. So just like before, we're going to figure out what is our question and how does that relate to our variables. We're going to come up with a quantity equation. So in this case, it's going to have to do with the amount of money. And then we're going to come up with an equation that has to do with the rates or the values there with those percentages. So my question is how much is invested at 8% and how much at 9%? So just like before, I'm going to be very specific in my variables. X doesn't equal 8%. If anyone writes that on their paper, you will get points deducted because now you're telling me wrong information. X does not equal 8%. X is the amount that is invested at 8%. Y is the amount invested at 9%. First piece of information is a person has $200,000 invested. That is my quantity. That's the total amount of money I have. Well, if X and Y equal the amount of money at each rate, adding them together should give me $200,000. Next is the trickier part, and it has to do with those rates. I know that the total yearly income for the two investments is $17,200. So going back to very simple interest, if I take 8% and I multiply it by the amount, that's going to give me how much I make at the end of 1 year. Because interest is equal to the principal, that's how much is invested, times the rate, and then times the number of years. Here we're talking about 1 year. So 0.08 times X gives me how much money I earned after 1 year. Similarly with the 9%, 0.099% times the amount that I invested at 9%, which is Y, will give me how much money I earned in that 9% investment after 1 year. Adding those two investments together, I should get $17,200. Rate times the amount invested plus the other rate times the amount invested is equal to the total income that is earned at the end of 1 year. So this, again, all goes back to simple interest. Again, I have a system of equations. I could decide how I want to solve it, either with substitution or elimination. I tend to do substitution with these problems because it's a little bit easier than trying to cancel out a variable, but you could pick whichever method that you like the best. I'm going to solve that top equation for either X or Y. In this case, I chose Y, but you could have chosen X. And then we're going to substitute it into the bottom equation. Distribute that 0.09, we have 0.08x plus 18,000 minus 0.09x is equal to 17,200. Combine my like terms, and I also subtracted that 18,000. I get negative 0.01x is equal to negative 800. Dividing by that negative 0.01, I have x is equal to 80,000. Going back to find y, I get y is equal to 120,000. So $80,000 was invested at 8% and $120,000 was invested at 9%. Okay, let's go back and talk about our strategy for solving applications that involve more than one variable. And this is going to be true when we get into larger systems of equations. The very first thing is to, if you need to, underline or highlight what is the question you're trying to answer. In this case, we are trying to figure out how much money was invested. We have two different accounts that we're investing into, an 8% account and a 9% account. So we are going to be very specific in what our variables represent. X is the amount invested at 8%. Y is the amount invested at 9%. Be specific. If you were doing this for a job, they would expect you to be specific as well. The second step is to look at your information and start piecing it together. Generally, you will have one equation that represents a quantity of some sort. In this case, we're talking about money. In other cases, you may be talking about number of units. You could be talking about number of gallons of a solution. There's a lot of different examples that you could have, but you should always have one equation that represents a quantity. X plus Y is equal to the $200,000 investment. The second equation tends to be the trickier one. We kind of had information that was specific about that second equation where all we had to do was translate it. That's a nice, easy example that, okay, I could kind of figure out how to translate that. In this particular problem, we had to remember that simple interest is calculated with the principal and the rate. And at the end of 1 year, we're going to get our investment for our interest. So the percentage written as a number, not as a percent, we can't just stick a percent into an equation, times the amount plus, again, the number that represents the percentage times the amount is going to equal the total investment. After that, we're just using our strategy for solving a system of equations to solve our equation, and then writing our solution as a complete sentence that answers the question that was being asked.